Hey everyone, it's Mr. Anderson coming to you again one more time in Chapter 2, our unit on linear relationships. We're going to be talking today about Section 2.2.3 in our CPM textbook, and we're going to be talking about how we can use slope and intercept, the equation of line in slope-intercept form, to help us solve some problems. Our focus today is going to be the big race one more time. We've got the big race set up again, and we have some information that has been adapted from our book. If you're checking out this problem, the problem we're going to use for this is number 68. If you're checking this out, it will not match exactly what we have. However, it is going to be modified slightly, and we're still going to get the same things out of it. All right, so we're going to use the big race. We're going to take 6 bike riders or 6 trike riders, 4 of whom are your math teachers, and 2 of whom are the winners of the prior heats, Leslie and Elizabeth, right? You might remember them from a prior video. And we're going to figure out, given different information, who the winner of our race was. So our goal is going to be to graph these things, write an equation for each line. So we're also going to be writing an equation, and then figure out this third bullet here, who the winner of the big race is. Can't stress enough how important some of the notes you're going to get are. So go ahead and grab your math notebook out and pause the video, because trying a couple things might be worth your time here, right? Really facilitate that learning. So here we go. We have our 6 bike riders, and one of the things I modified is, rather than using riders A, B, C, and D, or 4 team members, what I did is I inserted the names of your math teachers. So Mr. Anderson, Mr. Bloomer, Ms. Roebling, and Ms. Tam are those riders. And we have different information for everybody, okay? And Mr. Anderson, for example, rides his trike 3 meters every 2 seconds and passes rider B 10 seconds into the race. The race is 25 meters long. Who is going to win, right? That's the question we're after. Well, I don't have enough information here for Mr. Anderson to graph a line. I do know he rides his bike 3 meters every 2 seconds, so I do know his speed, or in this case, the slope. Okay, 3/2. But we know that he passes rider B, but we don't know where rider B is after 10 seconds. So let's check out rider B, and that is Mr. Bloomer. Oh, the other important thing that I am going to highlight here, sorry. The race is 25 meters long. I'll show you what I did with that in just a second here. But let's jump over to Mr. Bloomer, and we'll make Mr. Bloomer blue. He gets the same head start as Elizabeth. Now, we don't know what that head start is, but we do know he gets one. All right? And then we also know that Mr. Bloomer rides 1 meter every 2 seconds. So there's Mr. Bloomer's slope. There's his rate, 1 meter every 2 seconds. Change in y, distance is changing over the change in time, x, right? Okay? Same question, though. Who's going to win the race? They give me information about Elizabeth, so let's go ahead and check out Elizabeth here. I'm going to just jump down to right here. Elizabeth is 4 meters into the race after 4 seconds, but is only 13 meters in after 12 seconds. She's having trouble with her trike. She's got a flat tire. Who's going to win? They don't give me slope here, but they give me enough information to find the slope. They give me 2 points. And if you look carefully, you guys will see it as well. They tell me, hey, she's 11 meters in after 4 seconds. Whoops, I wrote that incorrectly. After 4 seconds, she's 11 meters in, right? Because our time variable is going to be our independent one. It's our x variable. And then she is, let me see, 13 meters in after 12 seconds. So the second point is like that. Now, we have the ability to find a slope from these 2 points. We can take the change in y over the change in x. And when I work this out, this is 2/8. This is 1/4. Ta-da! I can also do something else pretty nifty with this. I can go to my graph, right? Let's check this out. Okay, here's my graph. I have 11 meters in, 11 meters in after 4 seconds and 13 meters in after 12 seconds. So at the point 4:11, I've got over 4 up 11, and you guys can count with me if you need, right? There's over 4 and up 11. And then I've got the point 12 meters in after 13 seconds, right? Is that what it is? Nope, 13 meters in after 12 seconds. So I've got the point 12, 13. So I'm going to go over to 12 and up to 13. There we go. All right, that's going to give me enough information to make that line. And what I can do, because I just calculated that slope, is I'm going to draw this line. I'm going to draw it just like that, and I'm going to draw it back just like this. And I can put in a little slope triangle here, and I can do a little bit of critical thinking. We know the slope is 1/4, and what that means for us is from any 2 points, Elizabeth is going up 1 over 4. Now, if that's true moving to the right, it's also going to be true moving to the left, except I want to undo that, sorry. It's also going to be true moving to the left, and it's going to work backwards. So I can take this point and I can go down 1 and over back this way 4, and now I've identified that y-intercept. And it looks like Elizabeth got a 10-meter head start. So way back up here, I've got Elizabeth's equation. I've got Elizabeth's equation as y equals 1/4 x slope times intercept, or times x, excuse me, plus the intercept. And that's actually really informing, because that gives me the same information about Mr. Bloomer. All right? We're told, hey, Mr. Bloomer's got the same head start as Elizabeth, so y equals 1/2 x plus 10. Now, you might actually be able to make some educated guesses about this, because you already know, hey, Mr. Bloomer's riding faster. He's riding 1 meter every 2 seconds. Elizabeth is riding 1 meter every 4 seconds. So you may actually know that Mr. Bloomer is going to beat Elizabeth 1 meter every 2 seconds. And you guys can see my line there. Okay. And it looks, it looks like we've got, what's it called, Mr. Bloomer already riding faster than Elizabeth. And you know what, ladies and gents, I realize I made an error here. I had a dashed line on here for the purposes of showing you where that finish line was. Look at, Anderson even made a mistake. I put it on the wrong axis. I've got to put that line because the race is 25 meters long. Whoops, there we go. Okay, so we've got that, and now let's keep going, right? Let's keep going. Let's do some more thinking. I'll move on. I can make some guesses now about Mr. Anderson, but let's see what Miss Roebling did. All right, Miss Roebling rode half as fast as Leslie, but got a 4-meter head start. Who is going to win, right? Okay, well, let's use purple for Miss Roebling. Okay, they don't tell me anything about the slope yet, but they do tell me her head start was 4 meters. So I'm just going to mark that down for Miss Roebling. All right, I'll get to Leslie in a second, but let's check out Miss Tam here. Miss Tam got a 1-meter head start and was able to catch up to Elizabeth in 4 seconds. Okay, well, that's actually pretty... Oops, you know what? We got to use a different color for Miss Tam just to make the graphing a little bit more visual. Let's use orange. B equals 1. And so we've got this setup here, y equals, mx plus 1. We're going to be able to figure that out if we use this information. She could catch up to Elizabeth in 4 seconds. Well, Elizabeth is the pink line. So here's what this means. Miss Tam got a 1-meter head start, not very much of a head start, but she caught Elizabeth in 4 seconds, meaning that after 4 seconds, they were in the exact same spot. All right, well, look at what's going to happen here. I mean, check out your graph. Look at how fast Miss Tam is riding, right? Miss Tam has already crossed that finish line, right? Mr. Bloomer, Miss Tam looks like she's going to cross that finish line somewhere right in here. Miss Tam's a speedster. Holy cow. Okay, let's keep on keeping on. We've got 3 lines graphed. I still don't know who's going to win because I don't have them all graphed. I can't see Miss Roebling, I can't see Mr. Anderson, and I can't see Leslie yet. So let's go ahead and do Leslie's line here. Leslie rides 2 meters per second and starts 2 seconds after the start of the race. Okay, well, here we go then, ladies and gents. Let me see, 2 meters per second. Her slope is going to be 2, right? 2 meters per second. Okay, so 2 over 1 or 2. And then she starts 2 seconds after the start of the race. This is actually pretty interesting. This is going to be what's referred to in this particular case as an x-intercept, because she doesn't start moving until right there. But then she starts riding at 2 meters per second. 2 over 1, up 2 over 1. So she's also riding pretty fast. Okay, so check it out. She's got the exact same speed as someone else. Oh no, I'm sorry, not quite. She doesn't quite have the same speed as someone else. All right, but what we're able to do here is we could work to finish this line, figure out this intercept. We could work down 2 and back 1, and down 2 and back 1. And what you'd find here is that, and I know this is not perfect because I'm off my graph, you'd find that this intercept would be -4, right? And you can throw in slope triangles for that as well. But here we go. Let's see. The intercept is -4, and we now have y equals 2x minus 4. All right, we're doing great. We've got an equation for Elizabeth, done. We've got an equation for Leslie, done. We've got almost an equation for Miss Tam. We've got an equation for Mr. Bloomer. Now let's finish this off. All right, Miss Roebling is riding half as fast as Leslie. So here we go. Leslie's riding 2 meters per second. So Miss Roebling is going to ride 1 meter per second. But she's got that head start. Let's see how that's going to play a role. All right. She's got a head start of 4. And she's riding 1 meter per second. Over 1, up 1, over 1, up 1. You know, Miss Roebling is riding pretty fast, but it doesn't look to me like this is going to get the job done. She's still not crossing that finish line in front of Miss Tam or Leslie. All right, now we've got 1, 2, 3, 4, 5 lines on that graph. Looks like we only need 1 more. You know what? I'm sorry, ladies and gents. One thing I'm still missing is right here. I've got to figure out this slope for Miss Tam. I've got to figure out that question mark. Let's go ahead and do that. We're going to use our graph and throw a slope triangle in there and do that figuring real quick. If I go from here all the way up to here and build a slope triangle, that's a rise of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and over 1, 2, 3, 4. All right, a rise of 10, a run of 4. That is the same thing as, just mark this down, 10 over 4. That's the same thing as 5 over 2. All right, so our slope for Miss Tam is going to be 5 over 2. All right, we've got Miss Tam's equation. We've got Elizabeth's equations. We've got Leslie's equation. We've got Miss Roebling's equation. We've got Mr. Bloomer's equation. We can see all of them. Right now, it looks like Miss Tam is in the lead, but we're still missing one line. We're missing my line. We're missing Mr. Anderson's line. Let's go ahead and figure this out. Mr. Anderson, you ride your trike 3 meters every 2 seconds. Pass rider B 10 seconds after the race begins. So rider B is Mr. Bloomer. That is the blue line. And I pass Mr. Bloomer right here. Looks like right here. And I get to ride 3 meters every 2 seconds. So my line is looking like this. 3 meters every 2 seconds. 3 meters every 2 seconds. Up 3, 1, 2, 3, and over 2. All right. Ladies and gentlemen, we're going to have something that looks like that. Okay, there we go. So I know the slope. I can look here. I can see that intercept is 0. I can see that Mr. Anderson's equation is y equals 3 over 2x. And if you want, you can go ahead and write plus 0, but remember, that is not necessary, right? Y equals 3 over 2x works just the exact same way. All right, we've got an equation for everybody. Let's reevaluate what we did. We took that equation from a bunch of different information. All right, this is good practice for us because we don't always have the same information given the scenario or life or the word problem. But then what we did is we used a little bit of graphing, and you could have done this by hand like I did. It's good practice. You could have done it using Desmos.com, also good practice. But we used the graph to help us figure out who in fact won that race. Now, the race was 25 meters long, so we drew that horizontal 25-meter line, and we found the orange line, which was Miss Tam. Miss Tam was our race winner. Ladies and gentlemen, that is the entire 2.2.3 lesson. We do have a little review preview, and in this particular review preview problem, you are going to want to check out the math notes right above it. The math notes right above it are going to review an old skill. They're going to help you out with that. And then for 71, just tackle parts A and B only. Thanks for watching. Have a great day.